Hello students, welcome to the lecture of Basic Concepts of Chemistry. In the last lectures, we had learned about the basic mathematical operations using scientific notations, and we had discussed about rounding off the numbers. So we had discussed that while rounding off, if the digit which is to be removed is less than 5, then the preceding digit will remain same. And if the digit to be removed is greater than 5, then the preceding digit will be increased by 1. And if the digit to be removed is 5, then there are two different rules. That is, if the preceding digit is even, then it will remain unchanged, and if it is odd, then it will increase by 1. So these were the rules of rounding off. Now, we will have to learn about significant numbers or significant figures. But before learning significant figures, we need to understand why we are talking about significant figures. And a very important concept of precision and accuracy. We had discussed in the earlier lectures that while carrying out some experiment, there is a difference between the true value and the experimental value, because while doing an experiment there can be different types of errors, which can be instrumental error, human error, or various other kinds of unavoidable errors. Some of these errors can be minimized, but still a certain amount of error or uncertainty still belongs in the experimental data. Now, there are two terms to describe how much an experimental data is close to each other or close to the true value. These two terms are called precision and accuracy. Okay. So, precision means if we have taken multiple experimental data, then precision describes that how much each reading is close to one another, and accuracy describes how much these readings are close to the true value. So we will now understand what is precision and what is accuracy. Precision and accuracy. So by definition, precision means closeness of various measurements of the same quantity. Okay. Closeness of various measurements of the same quantity, or this can be described as how close the values are to each other. This can be described by a very simple relation to real life. That is, when people practice targeting, there is this structure which acts as the target, right? So this is the point of perfection, that is, this is the point where one has to hit. Now, while practicing, let's say a person has hit on these points. Okay. So these points are far away from the true target, but these points are close to each other. So we can say that this person has attained precision. but not accuracy. Okay. This we will see by the definition of accuracy. So what is the definition of accuracy? Accuracy is defined as agreement of a particular value to the true value of the result. Okay. Agreement of a particular value to the true value of the result. That is, while precision measures how close the measurements are to each other, accuracy measures how close the measurements are to the real theoretical value. So, you see, here we can say that this point is the true value. This is the true value, okay? So, this is the point that we need to reach. But in these cases, these points are far away from the true value. So, they cannot be called accurate. So, they do not have accuracy. But these points are close to each other. So, they are precise or they have attained precision. Now, let's say we have another target. Okay, and we have these points. So, here we see that these 2 points are much close to the true value, but these points are not. These points are far away. So, we can say that these specific 2 points have reached accuracy okay. So, these 2 points have reached accuracy because they are much close to the true value. But see, all these points are scattered. They are not close to each other. So, these points are not precise or they have not attained precision. Now, let's take another target. Okay. Here we have these points. Now see, these points are close to the true value as well as they are close to each other. So, we can say they have attained both accuracy and precision. Okay. So, this case was precise but not accurate. In this case, these 2 points were accurate but not precise. And these points are both accurate and precise. Okay. And let's say again, we have these points. Okay. So, these points are neither close to the true value nor close to each other. So, we can say that these points are neither accurate nor precise. So, I hope this is clear, the concept of accuracy and precision. Now, we can see another example with much more mathematical values. So, let's say in some experiment, we have the true value as 3.02. Okay, this is the true value. Now, let's say there are 4 students A, B, C, D. A have taken these measurements 2.85, 2.86, 2.88. B has taken these measurements 3.00, 3.01, 3.03. C has taken these measurements 2.90, 2.86, 3.05, and D has taken these measurements 2.72, 2.85 and 3.01. Okay. Now let's say where there is accuracy and where there is precision. So the values of A 2.85, 2.86 and 2.88. These values are close to each other, but they are not close to the true value. So we can say this has precision, not accuracy. Okay. Now the values of B 3.00, 3.01 and 3.03. These values are both close to each other and close to the true value. So we can say both accuracy and precision, right? Now the values of C 2.90, 2.86, 3.05. So these values are neither close to the true value nor close to each other. So we can say neither accurate nor precise. And these values of D 2.72 and 2.85 are far from the true value, but 3.01 is close to the true value. But these points are not close to each other. So we can say that this person has achieved accuracy but not precision. Okay. So when we conduct some experiment, we try to achieve both these cases. Both accuracy and precision should be tried to achieved. Okay. So this was the concept of accuracy and precision. Now we will study about significant figures. Significant figures. Okay. So significant figures can be defined as they are meaningful digits which are known with certainty. Okay. So they are written with significant figures are written with some certain digits and one uncertain digit. Okay. So the concept is let's say we have this number 312.5. Okay. So, this can be 312.6 as well as 312.4. So, in this case, 312, these 3 digits are certain. This 1 digit is uncertain. So, in case of any experimental value, we have said that there lies some amount of uncertainty. So, it is generally considered that uncertainty of plus minus 1 in the last digit is accepted. Okay. So, in some experiment, generally this much uncertainty is accepted. Uncertainty of plus minus 1 in the last digit. This is generally assumed even if it is not mentioned. Other uncertainties such as, let's say, plus minus 2 or plus minus 3, if these are the uncertainties, then it needs to be mentioned. Without mentioning, we generally consider plus minus 1 error to be there. So, now we will discuss significant figures, how to express them, and what are the rules of expressing significant figures. Okay, so we will discuss rules for determining significant figures. The first rule is all non-zero digits are significant. Okay, all non-zero digits are significant. Rule 2 is 0 preceding to first non-zero digit is not significant. Okay, so 0 on the left of the first non-zero digit is not significant. Let's say 051. Here this 0 is not significant. It is same as 51. Okay. Now 0.02. Here there is only one significant digit. Okay. Here the zeros before 2 are there to determine the decimal position and nothing else. So, there is only one significant digit, that is 2. The third rule says zeros between two non-zero digits are significant. Okay, let's say 203, 0.305. So, here this 0 is significant. Here this 0 is not significant, but this one is significant. Why? Because this was before the first non-zero digit, but this 0 is between two non-zero digits. Next one is zeros at the end or at extreme right is significant unless they are at the right of decimal point. Okay. Let's say if we write 10, then this 0 is significant. But if we write 10.0, then this 0 is not significant. Okay. This is significant, but this is not. The last rule is exact numbers have infinite number of significant figures. Okay. So, let's say 26. We can write and so on. Okay. Now, another thing that needs to be said is that when we are writing scientific notation, okay, let's say 8.13 into 10 to the power 2. In this case, there are 3 significant figures, these 3. But we do not count the exponential part within the significant figure. Okay. So, there are 3 significant figures. So, in the next lecture, we will discuss about the mathematical operations of significant figures. Thank you.